So in this section, we're going to talk about covalent bonds. Covalent bonds tend to occur between non-metallic elements, hydrogen and oxygen, or carbon and oxygen. Elements on the right-hand side of the periodic table. Because most of these nonmetals have nearly filled shells, they're okay with just sharing a couple of the electrons that are laying around. They only need one or two. The other element only needs one or two, so they can share the one or two that they have, and everybody's fine. And so mostly nonmetals form covalent bonds, but they can form different types of covalent bonds. Single, double, or triple bonds can occur, right? So if we have hydrogen, hydrogen has just one extra electron on the outside. And so they can essentially, as you saw in that picture a minute ago, share those two electrons. This one can go over here sometimes, this one can go over there sometimes. And they can share more than one electron. So oxygen shares two electrons with the other oxygen atom. I'm not going to try to draw that, but this would form a double bond. Nitrogen forms three covalent bonds with the other nitrogen atom when it forms N2, and you have two nitrogens side by side, or in the same molecule. Covalent bonds can have different outcomes. So if the electrons are shared evenly, as we saw in the hydrogen atom, then there's no real net charge distribution on the molecule. If the electrons are shared evenly between the two atoms in the molecule, then sometimes it's in one place, sometimes it's in another, but on average, they're all over the place. In other words, if we go back and look at that motion of the electrons around the hydrogen atom, there's no point where it's spending more time with one nuclei than the other. Okay, these are called non-polar covalent bonds. There's no charge or no polarity to the charge inside of the molecule. This generally happens with molecules where atoms are paired with themselves. Right? So H2 is a good example, because as you saw in the picture, those atoms are essentially the same size. And so those electrons are attracted to them at the same rate, and they kind of make a figure eight around those two hydrogen atoms. Now, if the electron spends more time with one atom rather than the other, then an atom will become a little more negative in that region, right? And you'll get some kind of charge distribution. This is called a polar covalent bond. And the reason I mention this is because of water. A water molecule looks something like this: two hydrogens attached to an oxygen atom. The electron is going to spend a lot of time over here with the bigger oxygen atom. And so if the electron spends a lot of time over here with the bigger oxygen atom, then this side of the molecule will be negative. More time with the electron, more negative charge on that side, which makes this side of the molecule positive. So this is what they mean by polar. There are poles, electric poles, in the molecule based on where the electron is spending most of its time. So water is a polar molecule. It's a polar covalent bond. You see these polar bonds also in hydrofluoric and hydrochloric acid, and when hydrogen mixes with other halogens. And there are all sorts of other different types of polar covalent bonds that just aren't mentioned here.